Hi, welcome back. Today we're going to be talking about absolute value equations. So here, to solve absolute value equations, let's just look at the equation for a second. This is the simplest equation. So this says the absolute value of x is equal to 4. Well, when we think about the absolute value, what we want to remember is that there's actually two numbers that we can put in here for x. We know that certainly the absolute value of 4 is equal to 4, right? And remember, when we solve something, we're looking for values that we can replace x with in order to have the left-hand side equal to the right-hand side. So we know that 4 is something that we can think about. But also the value of -4 is something for which you can take the absolute value of, and you can also get 4. So there's actually two solutions here. Both -4 and 4 are solutions to this. So when we're solving absolute, and this is the simplest absolute value equation, there's going to be ones that are more, that are a little bit trickier to solve, or they take more steps to solve. So in order to solve it, we're going to go through a series of steps. We're going to use inverse operations to isolate the absolute value expression. For us, that was already done in this simple equation. Then we're going to rewrite the resulting equation as two cases that do not include the absolute value. So in this case, we would have taken the x out, at whatever expression is inside the absolute value, we're going to take that expression and set it equal to the positive value here, and we're going to set it equal to the negative value here, okay? And for us, that actually just solved it. So for us, it's very simple because these steps like sort of collapse into really two steps. But let's go to a more difficult case. So here, the first thing we do is want to isolate the absolute value. So the absolute value expression is this right here. Oops, I meant to get a highlighter here. Okay. So we want to isolate this thing. So everything inside the absolute value we're going to isolate. Well, how do we isolate that? Well, we see a 4 in front. So the first thing we want to do is divide each side by 4. Okay, so that gets rid of the 4, and this becomes 6. So here we have the absolute value of x plus 2 is equal to 6. Now, we've done this part. Now, what we want to do is we want to take, in order to take the expression outside the absolute value, you want to separate it into two cases. Something that's equal to 6 and something that's equal to -6. Because let's say the expression on the inside here was equal to -6 here. Let's say the expression on the inside was equal to 6. Well, that's perfectly fine because if this is equal to 6, then the absolute value of 6, as I pass it through the absolute value function, it still gets me 6. But the expression could also have been equal to something to -6, because as I pass the -6 through the absolute value, I would also get 6. So here I take the expression on the inside and I set it equal to 6, and I also set it equal to -6. And then I just go ahead and I solve the two cases here. So subtract 2, we have x is equal to 4, subtract 2, and x is equal to -8. So my solution set is -8 and 4, okay? And that's a lot like if you think about the absolute value function, right? So here, this would have been, this absolute value function would have been a shift left by 2, and it would have been a compression. So it would look something like this. And we would be looking for the intersection of this side with the horizontal line y is equal to 24, right? If I were trying to solve for it. Well, there's actually two values that are going to have it be equal to this 24. Another way of looking at it is this is what's happening geometrically, okay? Algebraically, what's happening is there's two numbers. I could put 4 in here to get 6 on the inside, then absolute value of 6 is 6. Or I could put -8 in here. -8 plus 2 is -6, but the absolute value of -6 also gets me 6. So that's why we're arriving at two cases. This is very similar to the quadratic equation, where we usually arrive at two cases. Sometimes we have one solution, but it has multiplicity of 2. Okay, let's do two more problems here. So here, remember, we want to isolate the absolute value expression. So in order to do that, I would subtract everything by 4. So I'd have the absolute value of x plus 3 is equal to 0 in this case. And remember, that's perfectly fine. And here, I'm going to split it into two cases. X plus 3 is equal to 0, and x plus 3 is equal to, well, this is interesting because it wouldn't just be positive. 0 is the only number with no sign, right? So I can't just say +0 and -0. So in this case, it actually collapses down to one case. It's similar to when the quadratic equation has one root with multiplicity of 2. So all I have to do is solve this equation. So we subtract this, we'd have x is equal to -3. So -3 is the only one that's going to work in here. Because if we think about it, -3 is the only thing that's going to get me 0 on the inside, and the absolute value of 0 is the only thing that when I add it to 4, I also get 4. So that's what's happening here. We just say that there's one solution. We don't say it has multiplicity of 2. We just say it's one solution, which is -3. Okay, here I'm going to subtract 8 from both sides. Don't be freaked out that the constant's on the left side here. That's -3 is equal to the absolute value of x plus 2. Okay, let's separate our cases. I like to split my page here. We have x plus 2 is equal to -3, and x plus 2 is equal to 3, right? So it's like just whatever -3 is, and it's actually, when you think about it, there's actually no solution to this one, because there's nothing that can go in this absolute value that can equal -3, right? So when I start to do this, I notice that, look what this is saying. This is saying that something that was put through the absolute value function arrived at -3. And that's just not going to happen, right? Another way of looking at the original function is, look at what we have here. This is saying that a parent function, so graphically what's happening is a parent function that's been shifted left by 2 and up by 8. So imagine it's up by 8, is it won't meet a horizontal line at 5. So there's no way something like this would meet a function like this. If I set this equal to y1 and this equal to y2, there's no intersection of those two functions. Okay, algebraically what happens is when you start to derive it, there's nothing you can put in here that would get a solution. So here, the solution we say, if you remember, is the null set, right? We can either write the null set like this, or we can write it with open brackets like that, okay? And that's the end of the lesson for today.